Welcome to a tutorial on analog electronics and basically on the FET over here. Okay, and in this tutorial we're basically going to see through a comparison. Okay, we're just going to perform or rather take you with a tour of comparison between the two types of transistors, basically the FET, okay, and the BJTs. Okay, so by the term FET here we mean we're just gonna include Jfets and Mosfets both together in this comparison. Okay, so in order to perform this comparison over here, I need a diagram. Okay, so just wait a second there. Okay, so there you go. That's the diagrams of the FET and the BJTs respectively, as you all can understand well from here. So here we have just taken as a reference the diagram of the the structural diagram of the JFET. Okay, so as you can see here, since this channel is made out of n-type semiconductor material, so it's basically an n-channel JFET. Okay, so there you go. It's basically an n-channel JFET over here, or rather I'll just write it down as FET. Okay, so basically it's an n-channel FET. Okay, and on the other hand over here we have the BJT, which is of course a PNP type BJT, as you can see, PNP type BJT. So here we go. We have on the FET here this terminal over here as the the gate, okay, which needs to be reverse biased. So since it's a it's an n-channel FET, okay, n-channel JFET to be precise, so we're just applying a negative potential over here at the gate terminal in order to reverse bias it. Okay, well then let's say we want to make the left terminal the drain and the right one as the source. So in order to do that, we'll have to apply a positive potential and a negative potential respectively on the left and right terminals. Okay, so apart from that, in this case, as you can see, in case of the BJT, well, this would be the base, okay, the middle one. Okay, let's just consider that the left one is the emitter and the right one, the right terminal, is the collector over here. So despite both the devices being three terminal devices, okay, there are basically a lot of differences between them depending upon how the way they work. Okay, so we'll just go on to our very first point of difference over here, that basically, as you can see from these two diagrams, okay, comparing them, you can see that in case of a FET, basically the current conduction takes place through the channel. Okay, that's the n-type channel over here, and this current conduction through the channel basically takes place primarily due to the majority carriers that makes up this n channel. Okay, but on the BJTs, on the other hand, you can see both types of carriers, charge carriers, as the holes and electrons, both participating in current conduction. So with that, we just come to our very first point of difference between the two devices, is that the FET is basically known as a unipolar device. Okay, so there you go, that's a unipolar device, but the BJT would be known as a bipolar device because of the fact that in case of the BJT, both the electrons and holes takes place in the current conduction over here, and that's how basically the BJT gets its name. It's known as a bipolar junction transistor, if you all would remember. Okay, so having that said, over here, if we take another look at the two diagrams over here, we can see that in order to make the FET, okay, that's the JFET over here, the diagram that we're just using here for a reference. Okay, we can see that the gate terminal over here needs to be reverse biased in order to operate the JFET, okay, as it in the way that it should be. So reverse biasing the gate terminal would cause depletion regions to form, okay, at the within the n-type channel over here. Okay, and this is with the reverse bias over here, we just reverse bias this channel and this gate junction right over here, as you can see. Okay, so now reverse since you can see that we're just reverse biasing this gate and channel junction over here, basically. So obviously it's quite obvious over here that the input resistance would be higher. And if you all would take for example the diagram of the the MOSFET. Okay, so let's say if this is the diagram of a MOSFET over here, so we're just gonna have a insulation layer over there, and upon the insulation layer we're just going to have a metal, the gate terminal. Okay, so here goes our metal terminal, so that's the gate. Okay, and here we have an insulator layer. Okay, so there you go, that's the insulator. Okay, so there you go. So now in case of the basically in case of the MOSFETs, what we can see here, that due to the insulation layer, basically what happens is that the input resistance over there is far more higher compared to that of the Jfets. So here we can just derive a common link between the two, that in case of both the Jfet and the MOSFET, the input resistances are comparatively much higher, since in case of the MOSFET there is an insulator present between the semiconductor bar, the semiconductor substrate and the gate metal terminal. And over here in case of the Jfet, since the gate terminal is being reverse biased, and a depletion region forms there. So basically we get to understand, and our point number 2 of the difference between the two just comes up over here. So basically the input resistance is higher in case of a FET device. So there we go. So input resistance higher. Okay, but in case of the BJT, as you can see over here, that in order to make the BJT work as the way it should be, then we need to forward bias the base terminal over here. So we need to apply a negative input voltage at the base terminal, and over here we would need to forward bias the base and emitter junction. So we would need to apply a positive potential at the emitter, and in order to reverse bias the collector and the base junction, we would need to apply a negative potential on the collector terminal. So there you go. Since we just forward bias the base terminal over here, so we can see that the input resistance of the BJT would be comparatively lower compared to the FETs. So there we go. We have our next point of difference over here. We can just see that it has got lower input resistance. So lower input resistance. So there we go. So apart from that, now we can see that since basically this device, the FET over here, since it's a unipolar device and the current conduction mainly takes place due to the majority carriers in the channel, so we can see that there is no reverse saturation current being developed inside the FET. So now we can have our third point of difference over here. We can say that there is no reverse saturation current. So no reverse saturation. So there you go, current. All right, so there it is. But on the other hand, the BJTs, as you'll have come across in the previous tutorials, so due to the collector base junction being reverse biased over here, we would have a small amount of reverse saturation current. So there you go. So there is significant amount of reverse saturation current. So I'll just write it down over here, significant reverse saturation current. Just give me a while, I just pen this down. Right, there it is. That's done. So that's our point number 3 of the difference. And now if we would take another look at the diagram, then we would just find again another type of difference over here. Now since we can get to see again from our first point of difference between the two types of devices, that is, since the FETs are unipolar devices and the current conduction basically takes place primarily due to a single type of carrier as compared to the BJTs, so and also they don't need to pass through any kind of junctions as such. So therefore we get to see another difference over here, which just comes out in this way, that the FETs comparatively are faster compared to the BJTs, since the current inside the BJTs would pass through junctions and then undergo the recombination process and all. So that's why the BJTs are comparatively, slower devices. So there you go. The FETs are faster and BJTs are slower, and that's why you'll find in your computer motherboards basically the FETs are preferred, okay, in cases where transistor switching is required. Okay, just that's for your homework. Just kindly check it out. Okay, so again, if you all would come back to the diagram again, then or rather maybe to the point number 3 over here. So there we go. Since there is lower amount of reverse saturation current in case of the FET, so therefore the noise produced in the FET is comparatively less. So we just call them or rather I'll just we'll just call them low noise devices. Okay, so they are basically low noise devices. Okay, but in case of the BJTs, now since the reverse saturation current over here, as you can see, is quite significant, so there you go, I just underlined that in yellow. So since the BJTs basically have significant amount of reverse saturation current, that's why they would cause greater noise in the output signal. So I'll just pen it down as something like here. So it causes comparatively they produce higher noise. Okay, so comparatively higher noise. Okay, so again, if we would take this point again, the point of the reverse saturation current again. So now kindly just take note of the fact that you learned in the BJT tutorial that whenever we would just reverse bias the collector terminal too much, then due to the reverse saturation current being quite high, they would just cause a phenomena known as thermal runaway. So there we go. In order to if the BJTs are comparatively reverse biased to a very high extent at the collector terminal, then they would undergo the phenomena of thermal runaway. So I'll just put it like this, that there is a possibility of thermal runaway. So when the thermal runaway basically occurs in a BJT, then basically the BJT burns out. Okay, so that's the end of the device. But in case of the FETs, now since there is no junction that would be reverse biased, no matter how much voltage we apply across the drain and source terminals, so there is no possibility of thermal runaway. So there we go. So this is of course an end to a trouble, okay, possibly that is present in case of the BJT. So there is no possibility of thermal runaway. Okay, so there you go, no possibility of thermal runaway. All right, so that's quite a relief in case of the FETs compared to that of the BJTs. So now there we go, we have come across all sorts of differences between the two types of device, and finally we'll come to the last point of difference over here in this tutorial, that the FETs, inside the FETs basically we would control the amount of current that would flow through the channel in the FET device, okay, by means of controlling the reverse bias voltage on the gate terminal right over here. But on the other hand, okay, in case of the BJTs, what happens is that the amount of base current, okay, so amount of base current, which is just referred to as the IB, okay, would control the amount of current that would just be outputted by the device. Okay, so the base current would basically control the amount of output current from the BJT basically. So now here you can see that since the FETs are basically in case of the Jfetv, since this gate and channel junction is basically reverse biased, so the gate current would be approximately 0, or rather the gate current basically doesn't exist at all. And in case of the Mosfets, so there is an insulator layer there between the gate terminal and the semiconductor substrate, that's in which basically the channel would be formed. So again over here there would be no gate current at all. So since there is no gate current, okay, the voltage present on the gate terminal over here as well as on the MOSFETs, okay, would control the amount of current flowing through the channels. So basically the FETs would be termed as voltage controlled devices. Okay, so there you go, voltage controlled devices. Okay, but in case of the BJTs, as I said, that the base current would control the amount of current flowing through the BJTs, that's the bipolar junction transistors in this case. So therefore they would be termed as current control devices, since the amount of input base current would just control the amount of current that would be possibly outputted by the BJTs itself. So okay, so basically having that said, we wrap up our discussion on the comparison between the FETs and the BJTs right here. So let's hope that you've understood all the points discussed in this tutorial and have enjoyed at the same moment. So kindly check out our next tutorials on electronics, and till the moment it's just goodbye for now, and thanks for watching.